When you think about it, clean water, the milk in your fridge, even life-saving medicines, what's the one thing they all have in common? Well, they all depend on this incredible but kind of invisible technology. Today, we're going to pull back the curtain on the hidden world of filtration.
See, at the heart of it all, you've got these things called membranes. They're basically filters, but they're so incredibly fine that they can separate stuff at a microscopic level. They're super efficient, they don't use a ton of energy, and honestly, they're the gold standard for making things pure. They really are the unsung heroes of our modern world.
But every hero has a weakness, right? And for these membranes, it's the same problem your coffee machine has. They can get clogged. And when a filter on this industrial scale gets clogged up, well, the consequences are just enormous. This whole clogging problem actually has a scientific name: membrane fouling. The best way to think about it is like plaque building up in an artery. This layer of gunk builds up, it creates resistance, it slows everything down, and it basically chokes the entire system. So the billion-dollar question is, how do we fight it?
All right, so how do we fight back? Well, first you have to understand the enemy. And it turns out membrane fouling isn't just one simple problem. It's a really complex battle happening on a bunch of different fronts all at once.
You've got four main culprits. There's organic gunk from, natural stuff in the water. There's inorganic mineral scaling. That's the same crusty white stuff you see in your kettle. You've got these tiny suspended particles called colloids. And then, my favorite, there's biofouling. That's literally living microorganisms creating a slimy film. And the worst part? A membrane is usually fighting all of these at the same time.
And the impact of all this, it is just staggering. Research shows that fouling can slash a membrane's flow rate by nearly 34%. I mean, just imagine if a third of your city's clean water supply just vanished. That is a massive, massive drop in efficiency that costs a ton of time, energy, and money.
So, scientists are basically tackling this from two main angles. You can either change the filter itself, make its surface less sticky, or you can change the flow of the liquid to kind of blast the surface clean. Let's dig into that first one, changing the filter. Okay, so this first solution is all about material science. And the logic here is pretty simple, right? If you can just stop the gunk from sticking in the first place, you've already won half the battle.
Now here's the real challenge. Most of these membranes are naturally something called hydrophobic. Just think water-fearing. They actually push water away, which means they tend to attract all that oily, sticky gunk. So the goal is to flip that and make them hydrophilic, or water-loving. A water-loving surface creates this tiny, invisible layer of water that acts like a shield, repelling the foulants. It's exactly like a good non-stick pan in your kitchen.
And scientists have come up with two main ways to do this. They can either apply a special water-loving coating right onto the surface, kind of like painting it, or they can actually mix these hydrophilic additives right into the batter when they're making the membrane from scratch. But of course, there's a catch. When they're making these things, the process often involves a water bath. And what happens? Those super helpful additives have a nasty habit of just washing right out, leaving the final product way less protected than it was supposed to be. But here's where the solution gets really clever. It's a technique called vapor-induced phase separation, or VNIPS for short. Right before they plunge the membrane into the water bath, they expose it to humid air. It's a simple step, but it instantly solidifies the very top layer, creating this protective skin that traps all those precious non-stick additives inside. It's brilliant! And the results of this one little tweak are, well, they're incredible. Researchers found that by using this VNS method with an exposure time of just 5 short minutes, they could boost the membrane's lifespan by a massive 365%. That's not a typo. That's more than quadrupling its useful life just by locking in those anti-gunk additives. It's a total game changer. But okay, what if you can't change the material? Well, then you change the flow. So what if instead of tweaking the surface itself, you could just change the physics of the water flowing over it? That's the whole idea behind these hydrodynamic solutions. The principle here is really, really simple and kind of beautiful. By creating turbulence, tiny little swirls and eddies in the water, you can use the fluid's own energy to constantly scrub the membrane surface. It basically prevents those foulants from ever getting a chance to settle down and stick. And as you can imagine, engineers have developed a whole arsenal of cool innovations to create this self-cleaning turbulence, and they've gone from these clunky add-ons to some really elegant built-in designs.
The first idea was pretty straightforward. Just stick things in the water's path to stir it up. They're called turbulence promoters. And hey, it works. It can boost output by over 68%. But these objects cast a kind of flow shadow downstream. You get these dead zones where the water is calm, and you guessed it, the fouling can get even worse in those spots.
So, the next logical step was to ask, wait a minute, why not just make the membrane surface itself the turbulence generator? And that brilliant idea led to the development of membrane surface patterning.
And this is where it gets really fascinating. The actual shape of the pattern matters a lot. I mean, look at this. A diamond pattern boosted performance by over 68% compared to a boring flat membrane. A honeycomb pattern still gave you a nearly 46% boost. The design itself literally dictates how well the surface can clean itself.
In fact, in another study, this one for treating really tough, oily wastewater, researchers just inscribed a simple, wavy pattern right onto the filter's surface.
And the result? That simple wavy pattern extended the membrane's lifespan by 58%. It just goes to show that even really subtle, smart design changes can have a huge impact on stopping fouling and keeping these systems running smoothly.
So we have these two really powerful strategies, right? Smarter surfaces and smarter flows. And the obvious next question is, what happens when you combine them? Because that, right there, is the future of filtration.
This constant battle against clogging is driving some absolutely incredible innovation, both in materials science and in fluid dynamics. By creating these smarter surfaces and engineering more intelligent flows, we're getting closer and closer to a world where our most critical filters can just work flawlessly for way longer. And it leaves you with the ultimate question, right? Are we heading towards a future where fouling isn't even a problem anymore? A future where our filters can essentially just clean themselves?